Hello everyone. In this lecture, we are going to discussing about the simplex method. First question is why we have to use the simplex method to solve the LP model. LP model have more than two variables and are too large for the graphical solution method. Simplex is an important term in mathematics which represents an object in m-dimensional space connecting n plus 1 points. The simplex method examines the extreme points in a systematic manner, repeating the same set of steps of the algorithm until an optimal solution is reached. So due to this reason, we are calling this method is an iterative method. So now we have to see the simplex model. We already discussed. So this method is using for the when the decision variables are exceeding the 2. Let's see example. Maximize the x1 minus 7x2 plus 2x3. Here x1, x2, x3 are the decision variables which having the 3 numbers. In this type of the particular conditions, I have to go for the simplex method. And the first point is the constraints have no negative on right hand side, which means, for example, 4x plus 7y, here x and y are the decision variables, is less than or equal to the 24. If 4x plus 7y less than or equal to the minus 24 means, then we have to multiply with the minus 1 on the both of the sides. So then it will become the minus 4x minus 7y greater than or equal to the 24. Second one is the all variables should be no negative. So x1 and x2 dash dash it should be greater than or equal to the 0 only. And here possibilities of the inequalities. See, we know that when the two types of inequalities are there, one is the less than or equal to, another one is the greater than or equal to. First we have to look for the less than or equal to inequality. Let us consider 5x less than or equal to 50, which means, so any one decision variables we have to use availability of the resources less than or equal to the 50. Here 5x is representing the use of the available resources by the decision variables. Here 50 is indicating that one the limited of the availability resources. Then to fill the gap between the availability resources and the use of the resources, which means here we have to use the variable up to the 50, mean we have to complete the task 50 or otherwise less than the 50. For example, I completed the task by using the decision variables, so 40 only. Remaining 10 gap is there. To fill the gap between the availability resources, that is the 50, and the use of the resources, that is the 40. We have to introduce one variable, that is we are calling as the slack variable. And slack variable value is the positive value, that is representing the amount of unused. So next we have to see the second inequality, that is the greater than or equal to. Same condition I have to let us consider 5x greater than or equal to the 50. Here 5x is representing the use of the available resources by decision variables. 50 is representing the limited of the availability resources. For example, we have to complete the task, minimum we have to use the 50. Maybe sometimes it will be goes to greater than the 50. Let us consider availability of the resource is the 50, but we are using the 60. To make equality, so to extract the extra resources which we have to spend one. So it will become the 5x minus s equal to the 50. Here s we are calling as the surplus variable and it is having the negative value. This negative value, negative surplus of the resources. So just want to see the definitions of the slack variable and the surplus variables. First we have to see the slack variable. Variable represents unused resource either in the form of a time on a machine, labor hours, money, warehouse space, or any number of such resources. Similarly, you have to see the surplus variable. The variable represents the amounts by which solution values exceeds a resource. These variables also we are calling as the negative slack variables. Both of the variables, surplus and the slack variables, carry a zero coefficients in the objective function. So which means while representing the objective function with respect to these surplus and the slack variables, we have to introduce a zero coefficient. Mean for example 2x1 minus 3x1 plus 3x2. So plus 0s1 plus 0s2, like that we are representing. So thank you.